I've had to avert this week because of the Tulare County Fairs on my normal route here.
That'd be absolutely insane to go down that way.
But there's plenty of routes to go from the west side of Tulare to here, so I have routes, it's just my normal route. All right, chapter 5, review stuff. I think we might be able to get it done 2 days, we'll find out. I hope 2 days. This is day 10, day 8 lecture. We're going to start with scientific notation. It's where we have a number and it's equal to another number raised to a power or multiplied by 10 to some power. To give this a relative meaning, the mass of a dust particle is 7.53 times 10 to the negative 10 kilograms. And the mass of the sun is 1.989 times 10 to the 30 kilograms. That exponent n tells us how many times to move the decimal point. To get the real value. I'll say regular, the regular value. If it's negative, we move it left, and if it's positive, we move it right. Since I don't want to write 30 fucking zeros, I'm just going to do the mass of the dust particle. It's 7.53. And this says the negative 10 says move it left 10. So 4, 5, 6, 7, 8, 9, 10. If I move the decimal over here, I can pass by regular numbers, but if I start losing numbers or not having numbers, I gotta fill them in with zeros. So a dust particle is 0, 0, 0. How many zeros do I got? I got 9 zeros. 6, 7, 8, 9, 7, 5, 3 kilograms. And then I don't have any extra multiplier on it. That's not very much. Well, let me call you back tonight. I'm in class. Okay. So for scientific notation, there's only one number before the decimal place for scientific notation. So when n is greater than 0 or it's positive, it's a really large number. Well, it's a large number. Whether it's really large is dependent on how big that exponent is. When n is less than 0 or negative, it's a small number. You guys ready for Mark? Anyone still writing? Okay. Get off work at 7 p.m. Come on, Jeremy, I'll call you back then. All right. So let's do some practice stuff. We're gonna practice going back and forth between regular and scientific notation. So let's start off with two numbers. I want you guys to give this a try. If it's negative, move it left. And if it's positive, move it right. Give it a try, see what you come up with. I'm in charge I'm the advisor for the chess club. They just started up like they had me sign the paper 2 weeks ago. Their first meeting was last Friday. They had 30 fucking people already.
That many people?
That many people the first fucking week. We didn't have enough chessboards by a long shot. Like we brought like 6 or 7 chessboards. Nowhere near enough. So they're asking about because clubs can get money, a little bit of money when they open up to get some initial stuff. And then you have to fundraise after that. So they're asking about it. And they're like, can we 3D print them? I'm like, yeah, you totally can. You can actually make it a project in the Friday Night Labs that the STEM students do. They do to build shit on Friday Night Labs and they got a 3D printer. Like you can even make the COS Giant the king. Just whatever you do, don't make the other computer science teacher the king. And they said, why don't we, because there's 3D renderings of some of the teachers' heads. And they're like, we'll put them on the pawn. I'm like, yes, yes, yes. Make him the fucking pawn. That'd be great. All right, I'm hoping that you guys did this. You have the 5, 3, 6, 7, and we need to move it left 4 times, which means I need 3 extra zeros in front. And I'll put an extra 0 right there to make it clear it's not a 1. And this one's got to go the other direction, so it's got to go there, and it's got to go 3 more. So I'll have 6, 2, 1, 0, 0, 0, and I put the decimal there. And now I'll throw in a comment now that I know where the decimal goes.
If you add a comment, if the decimal point is on to the right of it. On the number,
Say that again?
so like, from the 6 to 1.
Yeah, the commas.
Oh, well, you don't really need to. But I put it there to, I'm trying to present it, so 621,000 without the decimal is the same thing as 621,000 with the decimal.
Oh.
I'm just trying to like make sure you guys understand what I'm doing here. Good question then. If we go the other direction. From regular to scientific. This goes in reverse. And you want only one number in front of the decimal point. So if I had 0.001234 and if I had 5, 6, 7, 8, 9, 0, 0, 0, 0. The way to go into scientific notation is move the decimal point right, counting how many times you do until there's only one number in front of it. I went too far. I got excited. So I moved this 3 times. This is a small number. So I'm gonna, the black number was a small number. So this is gonna be a negative exponent. And when I go the other way, I go 3 there, 3 there, 2 more here. I will have 5.6789. Those add up to 8 times 10 to the 8th.
But we have to turn it into that.
Right, if you have to go the other way. Is it kind of like what? Yes. Sig fig follows scientific notation.
Always one number. You move it till you get one number in front of the desk.
Yeah. I will give you guys some to try. So I switched up which one goes under which. Big numbers will end up with a positive exponent. Small numbers will end up with a negative exponent. I'm like a bomb. That's great. A lot of people are probably still writing, so I'll give you guys a chance to work this
I
out.
don't remember. So on this one here. You start from the end, or do you start from the? You
You
always
start from the decimal point,
There's no decimal,
so if there's no decimal, it goes at the end.
that's what I'm saying, at the end.
Just like $100 would be 100.00.
So you go, if you're gonna start at the end, and if it's the first number, if there's, then it's only gonna go to the, before the 9?
No, there's only gonna be one number in front of it.
Oh, one number in front of it.
Yeah, that's what I did spell it out. One number in front of it. So here, there's a decimal there. That's 3, total of 5. 5.43129, and it was a large number, so I'll make it a positive exponent. Here, that's 3, and that's 3. So I'll end up with a 7.62. 3 and 3 is 6, and it's a small number, so it'll be times 10 to the negative 6.
And then just, there's no point in just put one at the end. Go ahead.
If you don't have a decimal point, put one at the right side, yeah. All right. So multiplying and dividing. Not as bad as you might think. I constantly, I've had to fight this like 6 times already. I keep wanting to shorten scientific notation to sci-fi. That's fucking science fiction. That is. And sci not just sounds fucking stupid. Like not science. So let's say we've got 4 times 10 to the second. And we're gonna multiply this by 9 times 10 to the third. In fact, all of these are multiplied together. Two parentheses make it multiplication between it. And for some reason, we stick with the X for scientific notation. We don't put the point or the dot as a multiplier. But this is 4 times 10 squared times 9 times 10 cubed. And so we can swap the order of these and make it 4 times 9 times 10 squared times 10 cubed. That makes doing the 4 times 9 pretty easy. 4 times 9 is on the times table. That's 36. What about the 10 squared and 10 cubed? 10 squared, whatever that exponent is, tells you how many zeros are on it. So 10 squared is 100. 10 cubed is 1000. When you multiply those, and they start with a 1, it's just add up the zeros, and that's how many zeros are after it. 100 times 1000, there's 2 and 3 is 5 zeros. There's 5 zeros after it. Which means I can write this as 10 to the 5th power. The shortcut is we had a 2 and we have a 3 and now we have a 5. 2 plus 3 equals 5. You add them. So when multiplying by powers of 10, add the exponent. We're still not done with that problem. I want to go back to it, but want to make sure that's understood. So we had 4 times 10 squared and 9 times 10 cubed. And we saw that we got a 36 and we had times 10 to the 5th power. That was the 10 squared and 10 cubed. But if I put a decimal point in, it's got to go behind the 36, which means I don't have only one number in front of the decimal. So I can rewrite 36. 36 is 3.6 times 10 to the 1st power. Because I only moved the decimal once. And I still have times 10 to the 5th. Which means I can do the add the exponents again. Now, you don't have to do this step. If you can jump to the answer. For me, this mathematics was easy enough to do in my head that I didn't want to pull off the calculator. And I always have to really stop and think about which way to move the decimal when I have it like that, unless I write it as a power of 10. But you might be different. So why don't you guys give it a try? Three times 10 to the 4th power. And I don't know, 4 times 10 to the 6th power. So you should have gotten 3 times 4 is 12, and adding the 4 and the 6 gives you a 10. And then this is gonna give us, when we move to 1.2, that exponent should get 1 larger. You guys ready for some more? Is anyone still writing? Anyone have any questions? Okay. So let's look at division. I'm not doing a lot of each of these because I figured most of you are just gonna throw it in the calculator anyways. The problem is switching back and forth from scientific to regular. But. And I don't know that the calculator will do that. The calculator can't in some cases. It can't show you enough decimal places. So where we're gonna start off with is, like, we showed that multiplying powers added the exponents. When we divide, we subtract the exponents. 6 minus 4 would be 10 squared. And you can write it out. 10 to the 6th power has 6 zeros. 10 to the 4th power has 4 zeros. And it's kind of neat. As long as that first number is a 1, everything is good. And if it's only just one number, you can cross off the zeros in pairs. And we're left with 100, which is 10 to the 2nd power, like we would have got if we subtracted. So if you have a problem like this, 8 times 10 to the 9th power divided by 2 times 10 to the 7th power. Actually don't need a calculator for this. It's really quick. This is 8 divided by 2 times 10 over 9 divided by 10 over 7. 8 divided by 2 is 4. And that way we would subtract the exponents. 9 minus 7 is 10 squared. Now, you're probably not going to have integers like 8 and 2 if this shows up in the homework. They will try, they'll make you pull out your fucking calculator. So they might give you something like 3.14 times 10 to the 7th power divided by 2 times 10 to the 3rd. You can still do it in parts. I just don't know what 3.14 divided by 2 is. If you throw it in a calculator, you're going to get 1.57. And then 7 minus 3 is 4. So this is 10 to the 4th power. What would this number be out of scientific notation? This is just a quick check from a couple minutes ago. What? Say it again.
The 15,000?
Might be. Let's see. I gotta move it 4 times, 2 of them are there, which means I need 2 more zeros, yeah. It's 15,700. Good. Alright, the rest of the shit is not calculated work for today. It's some notes, some terminology. That we're gonna be using in chapter 5 a lot.
How would you solve it?
Depends on the calculator. I would convert to not being in scientific notation and just type it in that way. So like for this one, I would go, that's 3.14 times 10 to the 7th. I gotta move it 2, and then I need 5 more. So 314,000,000. 31,400 divided by 2, I gotta move it 3 times. Divided by 2,000. And I would do that. Or. Don't worry about the sign, do the sign, that's just adding and subtracting exponents. I would probably just do 3.14 divided by 2. And then do some basic arithmetic. I know you can handle the subtraction, Michaela. As much as you hate mathematics, that's some fucking first grade shit right there. Maybe second grade. I know you got it.
Say third.
Subtracting? No. You do a multiplication at least in 3rd grade.
I mean, maybe now, yeah, but back when I was.
And you aren't that far apart in age, and I was. Doing
What's going
space,
on? I went to early March, so yeah.
I wasn't in this town, I grew up in Sacramento. But
Maybe second.
Really hard to find.
I'm not saying you're like knowing math, multiplying well, you're just learning the times tables. Really. Alright, so. The non-mathy shit. Is intersection and union of sets. So let's say set A. I have 3 people in it. Arturo. Beta. And I don't know, fucking Clyde. Clyde sounds like a good name. We use curly braces for sets. And set B will have 3 people in it also. It's gonna have Clyde. Darian. And Edgar. I was gonna go with Elizabeth, but we already got close to that. So when we talk about the intersection of sets. Is what members or elements do they have in common? Did anyone answer that question for me? This set? What?
Clyde.
Clyde. Clyde's the only one in these two sets. The way we mark it is we say Clyde, we list the two sets. And intersection has a big upside down U. This means intersection of the two sets. And a fancy or a much easier way of saying in both sets is who is in A and B. So if you're seeing something, if you're looking for something that says and, this is an intersection thing. Now, if there was no intersection. I think there's a question on that homework or the support quiz that has it. If there's no intersection, like they have nothing in common, they'll have you put just empty braces, nothing in it. And it means empty set. The set's empty, there's nobody in it. I use people, but this could be anything that we could look at a deck of cards and we can go, where's the intersection between queens and hearts? We'll do that in a second, actually. Let's take a look at the other one, the union sets. The question here is what members are in either set? Or A or B. Or is the magic word here. Well, we have everyone in set A. Arturo, Beta, Clyde. Then we also have everyone that's in set B that we didn't already put. We don't want to mention Clyde again. It's the same Clyde. So Darian and Edgar. And we got curly braces here. I am spelling it right. It's two T's, right, Beta? Okay.
Like the fish.
Is it?
Yeah, that's exactly how solar fish beta.
I know that's not why she goes by Beta.
I know volleyball coach told me that.
Did they?
Yeah. They called you like a fish. Yeah. Oh.
That's a shitty looking curly brace. Let's try it again. Let's make it look good. All right, they don't say A or B, they will say A with a big fat U. This means union. Almost the exact opposite. It's not everything but Clyde, but it's everybody. It's important to note, don't include Clyde twice, even though he's in both groups.
Whoever's in there twice, don't you just do it?
Yeah, if the same thing is in both, you just write it once. Unless you know for certain they're different Clydes, but it's a fucking Clyde. How many Clydes you know? If you even know one Clyde, I'm impressed. The only Clyde I know is the fucking ghost on Pac-Man. Clyde is one of the ghosts on Pac-Man. It's the only one that's coming to my fucking head right now. No, there's Inky, there's Blinky, there's Pinky, and there's fucking Clyde. I don't know why there wasn't like a Dinky or, you know, something else. They fucking just went with Clyde. Okay, one more example. Has everyone in here used a deck of cards, at least at some point? Does anyone not know what a deck of cards is? Like, I'm gonna use this in today's lecture anyways. That kind of deck of cards. If you haven't used them, you're gonna have a learning experience. So a deck of cards has 52 cards. They're called playing cards nowadays. Because you could have like baseball cards and fucking, I guess Magic the Gathering is playing cards too, but it's not the same thing. Those are called collectible card games. That's a playing deck of cards. There are 4 suits. We have our diamonds. We have our clubs that look like a 3-leaf clover. We have hearts, which look like a heart. I guess I should have made the diamond red because it's a red color. And we have spades. And that looks like an upside down heart with a stem on it. These 2 are both red, even though I drew diamonds in black. These 2 are both black in a standard regular deck. Every once in a while, you'll see a funky version. It's got like blue and green and shit like that. What?
Spades look like a mushroom.
Okay. It's generally got a little bit of a point. A spade is actually a shovel. It looks like a non-square shovel tip.
What does the clubs mean? Like, what is that symbol?
It looks like a 3-leaf clover. I don't know where it came from. Some people call them puppy feet. Because they look like the pads, you know, like puppy pads. There's also 13, they're called ranks. There's 3 face cards, the Jack, which goes by J, has a J on it, the Queen, which has a Q on it, and the King, which has a K on it. Then there is A, 2, 3, 4, 5, 6, 7, 8, 9, and 10. A is called the ace. In some games it equals 1, other games it equals 11. And there might be even other games that have different assignments for it, but the standard ones are 1 or 11. So we could look at Queen Union Heart. And we can look at Queen Intersect Heart. So for the Queen Union Heart, there's 4 queens. One for each suit. And then we look at all the cards that are in hearts. We have ace, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and then Jack. And we don't want to count Queen again because we already counted Queen once, right? So we won't count Queen again. We got King, which means 12. So there are 16 cards among Queen and hearts. It's usually a fat U. It's usually not like a capital U. It doesn't look like when it's typed, there's a character for it. It looks wide. It doesn't look like a regular U. It's thick. Where queens intersect hearts. There's only 4 queens. There's the queen of diamonds, queen of clubs, queen of spades, and queen of hearts. And we're looking where the queens intersect the hearts. There's only one of them. So queen union heart is just one. And we'll wrap that. That'll be the end for the lecture for now. We gotta take 10 minutes for a break before we start the next class.